This is problem 10.44 in AOPS Introduction to Number Theory. It says, find the smallest integer greater than 2 that has a unit digit of 2 when written in base 3, base 4, base 5, and base 6. And you can leave your integer as a decimal integer. So basically at base 10 integer, you don't have to change bases. So what does this problem actually want us to find? I guess the problem is there, but how do we change this to something easy to find, or at least something that is not that confusing as something we want to find now? So we want to find a number firstly, and the smallest integer that is greater than 2, and it has a unit digit of 2 when written in all these bases. So what does this mean? Let's look at a few examples. For example, the next integer that is written that has a unit digit of 2 when written in base 3 is 1, 2, or 12 in base 3, right? What is that equal to when you have these digit bundles? So it's 1 times 3 to the power of 1 plus 2 times 3 to the power of 0. When you try to convert this into base 10, that's what you get. Now just keep note of the 2 times 3 to the power of 0 here, or the 2. Now what about 12 base 4? That's 1 times 4 to the power of 1 plus 2 times 4 to the power of 0. Okay, so what about base 5? Well, I trust that it's the same thing, so we don't have to keep writing on, but let's just do it for clarity. So it's 1 times 5 to the power of 1 times 2 times 5 to the power of 0. Again, notice how there's a 2 over here. That's kind of something obvious and common, but if we notice this and we take use of it, it's going to help us. So notice how all these numbers, when you try to in base 2, base 3, base 4, and base 5, base 3, base 4, base 5, base 6, written with the next smallest number with a unit digit of 2, and unit digit of 2 has 2 times the base to the power of 0. So if the base is b, then it has 2 times b to the power of 0 in it. What does this mean? It essentially means if you divide this number, let's just call the answer x. If the answer is x, so this number x has the unit digit of 2 when written in base 3, 4, 5, 6, then essentially what this means is x is firstly not divisible by 3, 4, 5, or 6, because if x is divisible by 3, 4, 5, or 6, it would have a unit digit of 2. And secondly, when we divide the x by 3, 4, 5, or 6, it has a remainder of 2. So we want to find numbers such that when x is divided by 3, 4, 5, or 6, the remainder is equal to 2. So how do we find such number? Well, firstly, so one way to do this is, I think what we should do is we should find the lowest common multiple of 3, 4, 5, 6, and then add 2 to that number. So the LCM of 3, 4, 5, 6. Now, what is that? Now we know that the LCM of 3 and 4 is 12. So this is basically the LCM of 12 and 30, because the LCM of 5 and 6 is 30. So the LCM of 12 and 30 is basically, let's see. So that's 4 times 5. Okay, so that's 60. So 4 times 5 times 3, that's 60. So 60 is the lowest common multiple. Now, basically that means it's divisible. So in this case, it's the smallest integer possible that is not 0, that is divisible by 3, 4, 5, and 6. This means that if we add 2 to this integer, which gives us 62, when we divide this integer here by 3, 4, 5, or 6, it will give us a remainder of 2. So we try to convert 62 into base 3, base 4, base 5, and base 6. It will give us 2 times b to the power of 0, depending. So b is the base you want to convert it in, namely 3, 4, 5, and 6. So our answer is just 62, and we leave it as a base 10 because it says you can leave your answer as a decimal integer.